Hello friends, in this lecture we are going to study about the trigonometric functions of sum and difference of angles. So here you can see a bunch of formula listed down here. So this pretty much summarizes all the formula we are going to need for trigonometric functions in class 11th. And over the course of next two lectures we are going to prove each of these. So this may look a big list in the beginning, but only hardly 7 to 10 of these are worth remembering. Rest all are just derived from one formula by just substituting values. Like you can see pi by 2 plus x. So if I know x plus y, then we can substitute x as pi by 2 and y as x, and we can get the new formula. And some are just by changing signs. So in place of x, if we put minus x, we get a new formula. So here it's a big list, but in reality it's a very small list, maybe 5 6 formula, not more than that. So let's begin. So these two formula we have already seen in our previous lectures. This cos minus x is same as cos x, and sin minus x is same as minus sin x. Why? Because we had said that if we have a triangle, circle here, and there is a point P at an angle of x, and this center is at origin, that is 0 0, and this is radius r, then its coordinates are r cos x, r sin x. Or here the cos x, and let this is length a, and now I take another point P prime exactly at an angle of minus x. So this length would also be a, and this length is radius of the circle. So here cos x would be this, and this base is b. Cos would be b divided by hypotenuse, that is r, and cos minus x. So I am looking at this new triangle with minus x. Again here the base is same, b. There is no change in it. So cos x and minus x, cos minus x give the same value. So this is our x-axis, and this is y-axis, positive y-axis, and below we have negative y-axis. So here this y coordinate is negative here. So sine minus x is minus a upon r, which is minus of sine x. So this we have already seen in our previous class. So we will start with our third formula, that is cos x plus y So we will start with this formula. Once we prove this formula, then rest others will follow. So first, this formula we will prove using a diagram, and the rest we would not need to refer diagram again. We can just prove all the others using this one formula. Take a circle. So this makes an angle of x. O is our center, and this is point P1 at an angle of 0 degree. If we take this OP1 as reference, then this point P2 is at positive x angle from P1, and P3 is at positive y angle from P2, OP2, and let this point be P4. So this OP4 is at negative y radians from OP1. Now we will join this P1, P3, and we will also join this P2, P4. So the coordinate of this point is clearly, we will take it as a unit circle, so all the radius of the circle is 1. So the coordinate of P1 is x is 1, y is 0, P2 is at angle of x, so it will be cos x sin x. P3 would be, its total angle is x plus y, this angle. So it will be cos of x plus y and sine of x plus y. And the coordinates of P4 are its minus y. So it will be cos minus y and sine minus y. And cos minus y is same as cos y, so we will write it as cos y. So here is our formula for cos minus x is same as cos x, sine minus x is minus sine x. So cos minus y is cos y and sin minus y is minus sin y. Now if we look at this blue line P1, P3, so here angle P1 O P3, this is x plus y. This angle, this is x plus y, and I will write in green this another angle, this one, this green one. This is also x plus y, the absolute value of this angle, because its OP is at angle of x from OP1 and OP4 is at angle of y from OP1. So this complete angle is x plus y. So angle P2 O P4 is equal to x plus y. So if we see this, these are two triangles. So the green triangle and blue triangle. This is blue triangle. So obviously we had studied about congruence in our earlier classes. So if in two triangles, so we have triangle P1 O P3 and we have triangle green triangle P2 O P4. So we see that OP this side and this side, OP4 OP1 are same, OP2 OP3 are same because these are all radii, and the central and the angle P2O4 and P1O3, these are same, that is x plus y. So these two triangles are congruent, or how do we write? We can write either this or, so these are congruent using side angle side congruency. So the remaining side would also be same. So these two sides, so the remaining sides and angle of these two triangles would be same. So the side opposite to this x plus y is, in green triangle it's P2 P4 and in blue triangle it's P1 P3. So P2 P4 should be equal to P1 P3, or their square will also be equal. And if we have 2 points in a plane P1 P2 with coordinates x1, y1 and x2, y2. Then this distance is given as distance square. If this is d, then d square is x1 minus x2 whole square plus y1 minus y2 whole square. And why it is so? Because if the coordinate of this is x1, y1 and this is x2, y2, then this distance, this length is x1 minus x2, because this point is at x1 distance from origin and this point is at x2 distance from origin. So this difference is x1 minus x2. Similarly, this distance is y1 minus y2 minus y1. So in this right angle triangle, this hypotenuse square is base square plus perpendicular square. So this d, which is hypotenuse, its square is this. So now so that's why we can find what is the length of P2, P4, and we can also find the length of P1, P3. So P2, P4 we will write it as coordinate of P2 is cos x sin x cos x minus P4 is cos y cos y whole square plus y coordinate is sin x and its y coordinate is minus sin y. So minus minus sin y, it's plus sin y whole square. This is P2, P4 square. This should be equal to P1, P3 square. P1 is 10 and P3 is this one. So cos x plus y minus 1 sin x plus y minus 0. Minus 0 we will omit. Now we can expand it. So left side become cos x, cos square x plus cos square y minus 2 times cos x cos y. And second term is sin square x sin square y plus 2 sin x sin y. And we will expand the right hand side. cos square x plus y plus 1 minus 2 into 1 into cos x plus y. And second term is simply sin square x plus y. Now in our earlier lecture we had studied that sin square theta plus cos square theta is equal to 1. This we had studied earlier. So we will use that here. So we see cos square x here and sin square x. So in place of that we will write 1. Then we have cos square y and sin square y. So we will again write 1. And then we have uh, this term. So we can take common, minus 2 we can take common. Minus 2 cos x cos y minus sin x sin y. And on the right hand side we have cos square x plus y and sin square x plus y. So again this sum is 1 plus 1 we already have here, 1 minus 2 cos x plus y. So now this 1 plus 1 2 and here also 1 plus 1 2, that gets cancelled, and this minus 2 and minus 2 will get cancelled, and we are left with this right hand side is cos x plus y, which we have to prove. So we will bring this to the left hand side and this to the right hand side. So we will have cos x plus y on the left hand side, and on the right hand side we will have this term cos x cos y minus sin x sin y, and this is our first formula, and it's worth remembering, so you should remember it. So after doing 3-4 examples it should automatically get memorized. So we have proved this formula, third one. Now we will prove the fourth one. So the fourth one is very similar to third one, except that here in place of y we have put minus y. So next we are proving this formula. So in this formula just put y as minus y in cos x plus y. So what we will get? We know that cos x plus y is cos x cos y, this thing, and minus sin x sin y. So in place of x we put x, so it's cos x, and in place of y we put minus y. So y here is replaced by minus y minus sin x and sin minus y. Cos minus y is same as cos y, and sin minus y is minus of sin y. So this minus and this minus makes plus, and we are left with cos x cos y plus sin x sin y. So this was our formula here. So we have derived this formula from first formula just by putting minus y in place of y. Now we will move to our next formula. So we are done with this. So next is this. So we already know cos x minus y. So this is our x, and in place of y we have x here. So in this formula just put the first term as pi by 2 and the second term as x. So what we will get? We will get cos pi by 2 cos x plus sin pi by 2 sin x. And cos pi by 2 is 0, so this complete term becomes 0. Sin pi by 2 is 1, so 1 times sin x is sin x. So this cos pi by 2 minus x is sin x. We can prove it quickly in our mentally also we can prove, but uh, it should be, it's good to remember it. It's very helpful. You cannot always put the values of x and y and then derive it. So next we have sin pi by 2 minus x. So next is sin pi by 2 minus x. So we have seen that if sine of x is same as cos pi by 2 minus the same angle, so we can write it as cos of pi by 2 minus this complete angle. So this sine x is same as cos pi by 2 minus that same angle. So this pi by 2 minus this angle, let's say it's alpha. So then pi by 2 minus alpha, and alpha we will expand. So these two terms cancel out and we are left with cos x. So these two formula are very symmetrical, like cos pi by 2 minus x is sin x and sin pi by 2 minus x is cos x. So we have proved these two. Now we will prove the seventh one. So sin x plus y, so sine of any angle is same as cos pi by 2 minus that angle. So we have used the earlier formula that sin x is equal to cos pi by 2 minus x here. Now we can expand this. We know the formula of cos x minus y. So cos x minus y is cos x cos y plus sin x sin y. So this will be cos pi by 2 cos x plus y, or this is coming in terms of x plus y, so better take these two. This way we can prove. So this is one angle. So this is one angle x and this is one angle y. So we will write in terms of this. First angle is cos pi by 2 minus x and second angle is y. Cos x cos y plus sin x sin y. Sorry, here it becomes cos x minus y, cos x plus y, so it will be minus here. And sin y. Now cos pi by 2 minus x is same as sin x, and then we have cos y, and minus sin pi by 2 minus x is cos x, and then sin y. So it was a mistake here, so it should be plus here, because we have expanded this pi by 2 minus x, so better write that step. Pi by 2 minus x plus y, and then we had expanded this minus x minus y, and then taken this first two together and then the second one. So this is our formula for sin x plus y. Now we will prove sin x minus y. So in this formula we just put minus y in place of y, and here also minus y. Cos minus y is same as cos y, and sin minus y is minus sin y. So we'll get minus here. So we have got the value of sin x minus y. So now we have proved these two. Now we will see cos pi by 2 plus x and sin pi by 2 plus x. So this we have to prove. So we can write it this value is equal to, or just use the formula of cos x plus y. We will get cos x cos y minus sin x sin y. Cos pi by 2 cos x minus sin pi by 2 sin x, and this cos pi by 2 is 0, so the complete term becomes 0, minus sin pi by 2 is 1, so we are left with sin x is equal to minus sin x. And now the next formula is sin pi by 2 plus x. So we can write it as sin x plus y is sin x cos y. So sin pi by 2 cos x plus cos pi by 2 sin x, and sin pi by 2 is 1. So we will write 1 times cos x is cos x plus cos pi by 2 is 0. This term becomes 0. So this is, so cos pi by 2 plus x is minus sin x, and sin pi by 2 plus x is cos x. So these two are also done. Now cos pi minus x and sin pi minus x. So again we will use cos x minus y, which is cos x cos y plus sin x sin y. So cos pi cos x plus sin pi sin x, and cos pi is minus 1, so this term becomes minus cos x, and sin pi is 0, so complete term becomes 0, so we are left with minus cos x. So cos pi minus x is equal to minus cos x, Now we will see sine pi minus x. So we can use the formula for sine a minus b or sine x minus y, which is sine x cos y minus cos x sine y. So we will get sine pi cos x minus cos pi sin x. Sin pi is 0, first term becomes 0, and cos pi is minus 1, so this becomes minus minus 1, so plus 1. Sin pi minus x is sin x, cos pi minus x is minus cos x. So we have proved these two also. So you see that we had just derived this third one using diagram, and then rest all we got from this third formula only. So it's a very important formula. If we remember one formula, we can derive others. So next we will see cos pi plus x and sin pi plus x. So this is cos x plus y form. So cos x cos y minus sin x sin y. So cos pi cos x minus sin pi sin x. Cos pi is minus 1, so minus cos x. Sin pi is 0, so minus 0, and it's minus cos x. Now we will see sin pi plus x. So sin a plus b is sin a cos b plus cos a sin b. So sin pi cos x plus cos pi sin x. Sin pi is 0, cos pi is minus 1, so it becomes minus sin x. Next formula is cos 2 pi minus x. We will not prove 2 pi plus x, because if we add 2 pi to any angle, it makes one complete revolution, which will be same as that initial angle. So cos 2 pi plus x is cos x, sin 2 pi plus x is sin x. So here we will just see cos 2 pi minus x. So it's again in the formula of cos a minus b. So cos 2 pi cos x plus sin 2 pi sin x. Cos 2 pi is 1, because cos 2 pi is same as cos 0. So this is 1 times cos x. Sin 2 pi is same as sin 0, which is 0. Now we will see sin 2 pi minus x. So this is again in the form of sin x minus y. So sin 2 pi cos x minus cos 2 pi sin x. Sin 2 pi is 0, first term is 0, cos 2 pi is 1, so it becomes minus sin x. So we have seen 13, 14, 15 and 16. Now we will see tan x plus y. So tan x plus y is sin x plus y divided by cos x plus y. So sin x plus y is sin x cos y plus cos x sin y, and denominator becomes cos x cos y minus sin x sin y. So this is in the numerator, the expansion of sin x plus y, and the denominator is expansion of cos x plus y. So now we can divide all the terms by cos x cos y. So uh, divide both the numerator and denominator using cos x cos y. So what we will get? So this term is, the numerator is cos x cos y plus cos x sin y, and denominator is cos x cos y minus sin x sin y. So we will divide everything by cos x cos y. So here cos y term cancels cos y, and we are left with sin x divided by cos x. So sin x divided by cos x is tan x, and here cos x cancels, so we are left with sin y divided by cos y, which is tan y. And in the denominator, this term cancels this term, so this is 1 minus this sin x divided by cos y, we can write it as this form. So a times b is same as b times a. So here I am just flipping this cos y cos x. I am writing cos y early. No, we don't need v. It's already in correct form. X terms are coming first. So sin x by cos x is tan x, and sin y by cos y is tan y. So this is our formula for tan x plus tan y. So tan x plus y. So now we will see tan x minus y. So in place of y we put minus y. So we will get, in this formula we just replace y by minus y. We will get tan x plus tan minus y divided by 1 minus tan x tan minus y. Now what is tan minus x or minus y? Let's is equal to sin minus y divided by cos minus y. And sin minus y is minus sin y. Cos minus y is cos y. So this term is tan y and with minus sign. So tan minus y is minus tan y. So we will replace tan minus y with minus tan y, and we will get tan x minus tan y, and in the denominator minus, and again this minus will come out, so it will become plus. So if we have tan x plus y, so if plus sign is there, so in the denominator we will have minus here, and if minus sign is there in the denominator we have plus here, and numerator is, if minus is there, minus is there, plus is there, plus is there. So the numerator and denominator signs are different. So you can remember it that way, like if we have tan x plus y, just write tan x plus tan y, and then denominator the opposite side, 1 minus tan x tan y. And if we have tan x minus y, then just write tan x minus tan y, and in the denominator opposite sign, that is 1 plus tan x tan y. So with this we will end today's lecture. So we have seen this tan x plus y and tan x minus y, and here we had written the condition, this x, y and x plus y should not be odd multiples of pi by 2, because for odd multiples of pi by 2 tan is infinity, so it is not defined. So this, if x plus y is odd multiples of pi by 2, this left hand side will not be defined, and if either x or y is odd multiple of pi by 2, then this term, these terms in the right hand side will not be defined. So these x, y and x plus y, these should not be odd multiples of pi by 2. So the others we will see in the next lecture, the other proofs. So stay tuned for next lecture. Thanks for watching.